Okay, this is the solution to problem number 15. Two forces are shown being applied to a block, and we're asked what the furthest, how far it's going to go in 10 seconds. So the nice thing about this problem is we're just asked about distance, direction doesn't matter. So we just need to get the magnitude of the force divided by m to give us our acceleration. So how do we get the magnitude of the force? Well, if we take the sum of the two forces squared, that's equal to the force 1 squared, or force 1 dotted with itself, plus force 2 squared, plus 2 times the dot product of the two forces. And what this actually gives you is the law of cosines relationship, that the magnitude of f1 plus f2 squared is equal to the magnitude of f1 squared plus the magnitude of f2 squared plus 2 times the magnitude of f1 times the magnitude of f2 times cosine theta. So if we want the magnitude of f1 plus f2, we just take the square root of this, which is the square root of this, and therefore we get that the magnitude of f1 plus f2 is the square root of f1 squared plus f2 squared plus 2f1 f2 cosine theta. Again, that's the law of cosines, but we can derive it by just taking the square of the sum. Once we plug in numbers, we can solve for f net, and once we know f net, if we divide it by m, that tells us a net. Now, we haven't derived the direction of the acceleration, but again, for this problem, we don't care. We just need to know the distance traveled in whatever direction that is. And so for that, we use the standard formula, the final position equals the initial position plus v0t plus 1/2 at squared. v0t is 0, and we want to know the furthest it travels from its initial position. So we really want to know delta t, which is df minus di. So if we bring the di over to that side, we get the df minus di equals 1/2 at squared. We just plug in 1/2 1.44 meters per second squared times 10 seconds squared, and we get 72 meters. So that is the distance traveled, and the answer is B.